In this video, we are going to go over the topics of chapter 22, which have to do with amines. First, we are going to discuss what the functional group amines encompasses. Amines are molecules that are derivatives of ammonia, and they can be classified as primary, secondary, or tertiary, as you can see in the box to the right of the slides. What makes an amine be primary, secondary, or tertiary is the number of carbon atoms bonded to the nitrogen. So R must be alkyl, meaning carbons with hydrogens. Understand that if R is aryl, meaning a benzene ring, then we're going to have a different class of molecules because those are going to be aniline derivatives. Understand that in nature, amines can actually occur, and they are known as alkaloids. These are going to be physiologically active amines. Understand that most of these amines that are alkaloids are going to be heterocycles, and what I mean with heterocycles is a cyclic molecule with atoms other than carbon, and specifically in the case of a heterocyclic amine, that atom other than carbon is going to be nitrogen. So as you can see here, we have three different types of alkaloids specifically. And understand that another feature of alkaloids is that they are derived from plants. So as you can see, the first molecule that we have is morphine, which is a potent analgesic. The second molecule that we have is cocaine, which is a potent stimulant. And the last one is nicotine, which is an addictive and toxic compound that is found in tobacco. Understand that other amines are also present in the human body. So for example, here we have three molecules. The first one is adrenaline. And adrenaline is the hormone that it is part of the signaling system for the fight or flight response in the body. And as you can see, looking at the structure of adrenaline, this is going to have a secondary amine. And remember that the secondary amine is because we have two carbon atoms bonded to the nitrogen. Here we have noradrenaline, which is a molecule that regulates the heart rate and dilates air passages. And if we look at the classification of the amine that we have, this is a primary amine present in the molecule, because as you can see, we have one carbon atom bonded to the nitrogen. Dopamine is another biomolecule that contains amines, and as you can see, this also has a primary amine, again because the nitrogen atom is bonded to one carbon, and specifically dopamine regulates the motor skills and emotions. in the human body. When we look at specifically the electron group geometry and the molecular shape of these amines, understand that specifically the molecular shape of the nitrogen atom is going to be trigonopyramidal. So that means that when it comes to it, if we consider what is going to be the partial charge that we find in these molecules, the nitrogen itself is going to have a partial negative charge. And remember that we can designate it with the symbol delta minus. Now, because of that partial negative charge that exists in the nitrogen, because of the lone pair that is present, that means that amines can act as a base. Now, they are, in essence, weak bases. They are not strong. But if you place them in acid, as you can see in the first square, it will get protonated, creating what is called an ammonium salt. One of the things that can be envisioned, in addition of that lone pair being able to deprotonate acids, is that it can also function as a nucleophile. And as you can see in the second box, that nitrogen is acting as a nucleophile on that alkyl halide and is allowing the nitrogen to be alkylated. In this case, as you can see, we can also be forming an ammonium salt, but this ammonium salt is a substituted one because now we're introducing more substituents to the nitrogen. So we can see in the Higgs diagram that is in the bottom of the slide that the electron density that is present on that nitrogen is going to be localized to the nitrogen. So the localization of the negative charges of what I'm trying to say, it is localized at the nitrogen because it has that lone pair present, and that is designated by the red area that we can see in the heat map representing the electron density throughout the molecule. Now we are going to go over on how to name amines. So understand that when we are naming amines, there are two different ways of naming primary amines. One of the ways in which we can name primary amines is just by naming the alkyl group ending with a YL, and then you are going to place the suffix amine on the molecule. So as you can see in the examples that we have in the slide, the first molecule, because we have a CH2, CH3 bonded to that NH2, that is ethylamine. The middle molecule is isopropylamine, because you can see that CH bonded to two CH3s, that's an isopropyl group. And lastly, we have a cyclohexylamine, because remember that we have a cyclic system, so all we're doing is just writing cyclohexane, which is the name of the substituent. We are just removing the ane ending and putting a YL ending and then adding the word amine. Understand that more complicated primary amines are named as alkanamines. So understand that in a way they are going to be named the same as alcohols, but then the suffix is going to be amine, okay, instead of the OL. Now, as you can see in the example that we have below, here the NH2 is going to be, let me just circle it. That's what makes the molecule an amine. Here we're going to find the longest carbon chain, which is going to be 7. And as you can see here, if you write the alkane name for that 7 carbon chain, you will think is at first heptane. And all we're doing here is deleting the E, adding the word amine. We are given the location of the amino group, the NH2, which that's why we have a number 2. And then in this molecule, the 4,6 dimethyl illustrates the location of the substituent. And in the beginning, because we have 2 chiral centers, so you can see one is highlighted in green, the other is highlighted in pink. That is placed as a parenthesis in the beginning of the molecule, the name of the molecule. Now, understand that the term amino, it is utilized for the group when NH2 it is utilized as a substituent. So as you can see in the example that we have on the left, if you have a molecule that contains an alcohol and an amino group, the alcohol takes priority in the numbering, and it is going to be utilized for the ending name for the longest carbon chain. So in the molecule that we have here, we have carbon 1, carbon 2, carbon 3, carbon 4. That's where your butanol comes from. In this name, it's missing in the slide, but it should be specified that that OH is on carbon 1, so the correct name for this should put a 1 in between the word amino and butanol. And on carbon 4, we have an amino group. So the corrected name is 4-amino 1-butanol. Now, if we have in a molecule a carboxylic acid and an NH2 group, understand that the carboxylic acid has priority. And an NH2 group is known, as you can see, as an amino group. And here, because your benzoic acid is going to be the longest carbon chain or the main name of the molecule, so I'm highlighting the benzoic acid in green. When we're numbering the ring, carbon 1 is what's holding the C double bond OOH. And then you can go clockwise or counterclockwise to give the amino group the lowest number. In this example, it doesn't matter if we go clockwise or counterclockwise, the amino group is going to be always on carbon 4. So that's why the name of this molecule is para amino benzoic acid, or alternatively, you can put 4-amino benzoic acid. Now, if the amine is directly attached to the aromatic ring, then the parent chain is going to be aniline. This is what I explained a few moments ago when I introduced in the first few slides the different type of amines that can exist. Now, understand that it is very important to note that substitution can happen within the ring system. So as you can see, the first molecule is designated as aniline. So whenever you have a ring system with an NH2, that is going to be your aniline. So if I highlight it here in the slides, this is going to be your parent chain in terms of naming, which is aniline. And then, as you can see, when we have this system, we can number clockwise or counterclockwise, but always remember that the carbon atom in the ring system that is holding the amino group is going to be carbon 1. In this molecule, we have to number clockwise, where this is 2, this is 3, and you can choose to write meta chloroaniline or 3 chloroaniline. Because the chlorine is on carbon 3. Now, in the last molecule that you see here, remember, we are going to have carbon number 1 being placed at the carbon that is holding the amino group, because the longest carbon chain is going to be our aniline motif. And in this case, we have to number the molecule counterclockwise. So this is carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. And the reason is because we want to give the substituents the lowest number. Remember that when we're naming the molecules, the substituents need to be alphabetized. And the numbers designate their location in that benzene ring system. Now, there are multiple methods for naming secondary and tertiary amines. Okay, so one of the methods is by just writing the names of the alkyl groups that are surrounding the nitrogen atom in your amine. And as you can see in the examples that we have below, the first molecule contains an ethyl, a methyl, and a propyl group, and those substituent names are placed before the word amine, and you have to place them in alphabetical order. Now, in the second molecule, we have two substituents that are the same. Here we have an ethyl group, and here we have an ethyl group. That's why we utilize the prefix di to symbolize that we have two of the same substituents on the nitrogen. And you can see that similarly in the last example, we have trimethyl because the nitrogen atom is surrounded by CH3s. Remember that amines is going to be the last word. Now, what if we don't have an NH2 group and there is substitution at the nitrogen atom itself? So as you can see, when we have complex amines like that, we're going to find the carbon parent chain, and we are going to use the suffix amine present in it. So as you can see, the parent chain is going to be the hexane, because overall this is an amine, then the final word is going to be hexanamine. Now, understand that the groups that are attached to the nitrogen are going to get the locant N to symbolize that they are bonded to the nitrogen atom in our amine. And as you can see here, the complete name for this molecule is going to be S 2,2 dichloro and methyl and ethyl and methyl 3 hexanamine. Okay, the 3 is the location of the nitrogen in the parent chain. The N's that are utilized in the ethyl and the methyl are going to illustrate the substituents that are bonded to the nitrogen, and the 2,2-dichloro symbolizes what is attached to that parent chain. Now, similar to what we have been doing in terms to naming, understand that every single one of these substituents, so the C in chloro, the E in ethyl, the M in methyl needs to be alphabetized, and before them we are going to place what is their locand.